Thank you. Good morning, everybody. So Neil Shepard here from BCG. Happy to spend a bit of time with you talking about telecom and blockchain together. So I've got a short presentation here. We're going to talk a little bit about getting on the same page about what blockchain is and why it's unique and what it does a little bit differently to traditional ways of storing and sharing data. We're going to talk about some of our findings in the rest of the world in terms of the different industries where we're seeing blockchain start to get some traction. That'll give you some idea of the momentum that we're actually seeing in the world just now around blockchain. And we're going to finish off with just talking a little bit about where blockchain is useful or most applicable within telecom, and give a few examples to whet your appetite about why blockchain is a particularly exciting topic and creates a bunch of new opportunity. So without further ado, I'm going to talk a little bit about what blockchain actually is, just so we're grounded on it. So you can think of this, the technical term is it's a shared digital ledger or distributed ledger technology. You can also think of this as a database. But the way it works is that you have multiple participants who all share exactly the same copy of the database. It's not like where you have islands of information within company firewalls or potentially within a regulator's firewall, etc. You actually share the data, and blockchain is great at sharing data across corporate firewalls. Also, there's one other thing I want to talk about that you've probably heard about: Bitcoin, Ethereum, all of these other cryptocurrencies. We're not going to talk about that at all. That's just a totally different area. It happens to be enabled by blockchain, but really the exciting thing for enterprises is private blockchain. I thought my voice was loud enough, but not. But basically, enterprise private blockchain are very high performance blockchain networks that allow a lot of the use cases that we're now talking about. So I'll talk a little bit about how they work. So first up, the way this works, and it does this in a very secure way, is when there's a new transaction that wants to be posted to the ledger, it's added to what's known as a block. And then it's encrypted based on not only the contents of that block, but also the content of what followed before it in a chronological order. And the reason this happens is that it basically checks that every entry in the database relies on every other, so that you have a very secure and tamper-proof way of storing the data. So you have all the parties that are those nodes that we showed on the previous page actually look at this, compare the digital signature of these different blocks, make sure they add up, they are the same, and then they vote to decide whether the block should be allowed or not. And in this way, you actually need a majority of the different participants in the network to actually agree before something's posted. If it's valid, it's added to the chain, and then you go for the next. So it makes it very secure. So a couple of things that are very different, and this is going to get into why this is a very different technology, is blockchain does things in a very different way to traditional ways of storing data. The first thing is you have a single version of the truth shared across all participants in the network. So everybody can see the same exact data, which means that it's very easy to actually do a lot more rather than have problems reconciling data, which is what happens in telecom and elsewhere as well. It's encrypted by default. A very important point is it eliminates or can eliminate intermediaries. So in many cases where you have businesses where you don't really want to trust one person with your data, blockchain's an excellent solution where you can be sure that you don't have to do that. The fourth thing here is that it unlocks new business models. And the exciting thing here is that if you had situations where because you couldn't share the data in a secure and sensible way without intermediaries, you're now able to create what looks, in many cases, like a network effect business. So we'll talk about some examples like that, but basically, you couldn't do these before. And then the final piece is, and this also gets to be quite exciting and one of the true potentials of blockchain, is it facilitates automation. And the reason for this is if you actually have a secure single version of the truth that everybody agrees on already, why can't you write contracts or rules, we call them smart contracts, that operate on that? If you have the data, use it. And then you have automation, you have immediate access to contracts or to transactions that are approved. You can be paid immediately if something is approved. It's a very, very powerful tool. So what we have now is some examples. Now this map here is, in a way, it's a bit blinding by science. But this is the evidence of what we see blockchain showing up in terms of use cases and in industries around the world. So literally, we see here supply chain is a very large use case, financial services, I'll go through some examples here, but we've mapped out many of the different use cases we're seeing see traction throughout the world. And to be quite frank, we couldn't probably have done this 2 years ago. It's taken quite a while to actually identify where the space is, where blockchain has its unique advantages, because this is not really, full disclosure, it's not an easy technology to understand. So it takes a while for this to mature. Now, why these use cases have shown up is because they actually leverage some of the capabilities of blockchain that we saw on the previous page. They allow transactions in a very secure way, they allow sharing of data, and in many cases, the fact that you don't need an intermediary is very valuable. And in the example of supply chain, we've had examples, particularly in the electronic supply chain, where people have decided that they want to use blockchain to orchestrate their supply chain. But you have multiple different vendors, multiple different suppliers, who all take possession of a module that they then send on to the next person to finish it, or a distributor, or whatever else. And they can't share a single point of contact for that. If you're a large electronics provider, are you going to trust your competitor to manage that data? Not a hope. You have to use something like blockchain. Other examples of this are in financial services, where we're seeing this being used for transactions, across sort of for stock trading, for bond trading, for collateralized debt, etc., and also for things like loan agreements, where you have credit financing or trade financing. If you have blockchain and you put an invoice in there saying, I have $2 million worth of goods that I want to finance, and you know that that $2 million invoice is correct, then you can get financing at much lower rates. But you can't do that unless you have something like the blockchain to put this on there. Then we have other examples, marketplaces, etc. People are using this for things as diverse as settling air miles between airlines. We're seeing that with Singapore Airlines and others. And identity management, again, another thing where we're seeing a lot of action, particularly around governments, where they're looking to modernize their infrastructure for managing people's records or business records, etc. So some fairly progressive governments like Estonia and elsewhere are actually doing a lot to digitize using distributed ledger technologies in the blockchain. And the final piece here is autonomous M2m interactions, where we're seeing for particularly IoT and M2M applications, people are using blockchain at the edge. So not only it can provision some of this equipment, and we'll see that this may relate to telecom as well, but also it provides a very resilient way of allowing transactions and micropayments between machines, and without relying on a central database to manage all of the volumes. So a big map here, and I'm going to just share very quickly some of the momentum that we're seeing in some of these examples. So just to point out that this is actually moving very quickly, this is a little map here of just the last year of all of the action in supply chain. And I know we're not here to talk about supply chain, but this is a good example of what we've seen in an industry that's maybe a year or two ahead of telecom in terms of the adoption, but it's moving very, very quickly now. So what we're seeing here, I won't go into detail on all of these, is that in specific verticals, so for example, pharma, for the food supply chain, for the electronic supply chain, some fairly large moves are being made by some big players. So very interesting, in pharma they have a big problem with anti-counterfeiting. There's also challenges around managing sort of drug trial information, where right now it's being stored in islands of information and you need to protect it from hacking or all sorts of regulations around health data. But blockchain's an excellent solution for sharing that information. Two other examples I want to bring up, and this is one that I think is really exciting, is Walmart. Is actually, because it's a very, very, very powerful retailer, is actually forcing forcing is maybe not the right word, asking its vendors to use a blockchain to do track and trace in all of the food, so that if you have from farm all the way through to Walmart itself, if there's a recall for some food that has bacteria or whatever else it is in it, you can quickly identify the source of that and stop it and then move on and do the recall. So a lot of savings to be done there. And then the other ones that we've heard about, like Maersk and IBM, doing revolutionizing shipping using blockchain. And finally, even World Wildlife Fund has created an ethical product blockchain that allows us to track and trace where products came from. A lot going on here. So let's talk a little bit about where this applies in telecom. So we've identified many use cases in telecom, and again, this is a relatively early stage of the development here, but there are three basic categories. The first is under infrastructure management, so things like supply chain, full life cycle track and trace. The second is around cost and efficiency. And then the final one is enabling new business models, which hopefully will allow increased ARPU or various other things that are big benefits, where we think that telecom providers are very well placed to do something good here. I'll jump into a couple of examples here and just go through some of the potential here to whet your appetite. But some examples are under infrastructure management we're seeing. Supply chain we actually talked about, but it's the same idea here. Where's my stuff? And frankly, what does it have in it? One of the other use cases we're seeing with network equipment and for cyber insurance, which is a brand new category, is using the blockchain as a way of actually controlling and understanding and knowing what configurations have been put on the equipment, what software patches, what updates. And if you do that and you have a verifiable record of what has been done where and what the configurations are, you can get cyber insurance. So lots of things that are good for that. Another one is under IoT device provisioning and management. So people are using the blockchain to actually sort of authenticate devices and provide a channel to actually send the data back when they have IoT sensors creating data. So two other things that are the big categories: intercarrier settlement, I'll have an example of that, and roaming authorization. And then the final one is around new business models, most of which is really based around identity as a service. So if you know the customer's identity, you can layer on these additional business models. So privacy and preference management, which we'll come to. Payments, for example, it's a very logical use case to jump into. And then things like loyalty management for programs. There's one other here, which is around digital rights management for media and so on. But basically, there's a lot of different use cases that can be enabled. Once you know the identity and have that in the blockchain, you can add these things on relatively easily. So, a couple of quick examples here, just in a little bit more detail. This example here is for automating roaming agreements. So today on the left, we have the examples of how it typically works. You have a roaming agreement with different carriers, and what will happen is a roaming user will visit a different network. There'll be a call data record created, it'll go through a data clearinghouse, and then once the data clearinghouse has passed the information on, etc., there'll be a payment released at a certain time in a certain place. Now, to be clear, it's sort of, from what I understand, it works quite well, but there are a few disadvantages, and the biggest one that I'm hearing is around roaming fraud. So frequently a SIM will be created that will basically be allowed to use services to which the user is not allowed, and that'll create fraud, which the latest numbers I've seen have been around $11 billion a year globally. So it's a pretty large amount of money to be losing. And in the blockchain scenario, you're able to actually stop a lot of that. So the difference is with the blockchain, if you have multiple carriers all on the same blockchain network, they're able to see the same information about the authentication of which user is allowed to use which services. And that's also really interesting, is that you're also able to hit the blockchain to authenticate a user, see what services they're allowed, and then using the blockchain, you can actually execute a contract, a smart contract, that will authorize the billing payment once the call or data service is completed. So a very nice set of rails and a very secure way of sharing the data across different carriers and automating this. And the best estimates are that this will save a great majority of some of the roaming fraud that's out there. So good use case. This one's on the cost side. Let's talk a little bit about a use case around identity as a service and some of the things that we can layer on from that. This is the typical scenario on the left again. So you have two things going on here. One is that users would love to be able to access services. These could be government services, these could be bank services, etc. But at the end of the day, they're being held back because the level of security required may just not be sufficient for the healthcare providers or whoever else to actually release the information. On the other side, you have advertisers that are trying to reach users and would love to be able to actually sell products and services in, ideally, a legal and authorized way. The reality is it's a very inefficient and fragmented market, particularly for advertisers. If you're Google or Facebook, great. You've got great data, you know how to hit those users. If you're everybody else, it's much, much harder. And the reality is that understanding who the users are, targeting them by demographic, by what kind of propensity they have for buying certain services is very difficult. But if you were able to create an identity as a service and actually allow the consumers to control what information they share, and allow the advertisers to access that in a secure way where they don't know who the end user is, but they know enough about them to target them well, then it's a win-win. And so a scenario that we see on the right-hand side would be a fully blockchain-enabled network where the users would control what access they give to advertisers. Each advertiser, a large advertiser, would have a blockchain node and be able to see, well, if I want to reach a certain pool of users with a certain demographic or a certain kind of profile of what they want to buy, I can do that. I don't know who they are, but I can do it. And so you're able to actually create in theory, an advertising network plus a lot of other services by leveraging this identity. So again, a very powerful capability with a lot of advantages over the existing ways to do things. Now, I'm going to talk a little bit about how this has basically worked in the past and some of the advantages and disadvantages that we've seen in blockchain so far. So it sounds all great so far, but the reality is, and I'm going to use a cricket term here, we're in the early innings of blockchain, and particularly enterprise blockchain. So some of the challenges that have been historically faced and are being addressed steadily as we speak are around the technological maturity. Blockchain as a technology is only 10 years old, and enterprise blockchain has grown enormously in the last 5 years, but there's still some ways to go around performance and scalability. It's being worked on very, very hard right now. The second issue is around business case clarity. This isn't easy to understand. And the map that I showed you a few slides ago is relatively new. We're getting a good idea of where this is, but many industries are really struggling to understand what can we do that's different that we couldn't do with blockchain, and it just is going to take some time. The third issue is around seeding the market. So if you're trying to create a new service or a product, and you want to create a network effect business, it turns out it's actually quite hard to do that in most industries because you need to corral a lot of people, you need to get a critical mass, you need to spend a lot of time advertising these new products and services to people who haven't had it before. And that's not typically easy. Now, we love the idea of these network effect businesses, but the reality is they're not easy to execute. Fourth issue is around ecosystem incentives. The incentives for participating, particularly in a complex scenario like supply chain, actually vary enormously. And we've looked at supply chains in the past in aerospace and automotive, and what we found is two things, and no surprise. One is that intermediaries actually don't like the blockchain very much. Shouldn't be too surprising. And the second is that actually the incentives to participate are very, very different. And you need to design that as part of your business model before you go out the gate. Otherwise, you will find that you'll hit a roadblock. Somebody just won't want to participate, and then you're not going to get the benefits you expect. So you've got to manage these very carefully. It doesn't mean they can't be solved. It's just things to think about. And then the final one is regulatory uncertainty. It's not necessarily the case that there's always problems with regulations, but typically regulations lag technology. And in cases like GDPR in Europe, where there's the right to be forgotten, which is something that blockchains typically try not to forget. They typically have a memory that lasts forever. So there's ways to get around that, but typically you need to think about how to design your blockchain and your system to manage around some of these regulations sometimes. Now, the good news is it's different in telecom. So I'm just going to conclude with something for you to think about here that's actually quite exciting and why this is a better technology for telecom in many ways. One is technological maturity. You're facing the same challenges as everyone else, but it's moving very quickly, and clearly the performance is there now. Under business case clarity, one of the best things here is that it's actually fairly obvious where some of the money is. The stuff that I mentioned about 4 or 5 slides ago about the cost efficiencies can be calculated fairly simply. Around the business models, it's relatively clear where the opportunity is, and the challenge here really is how to get it. Like, how quickly can you move? How quickly can one network operator or another actually capture that market and make these efficiencies happen? The second is around seeding the market. Telecom companies have an enormous advantage here. They've got millions of captive users to which they can market these new products and services. And also, in many cases, industry concentration means that if you want to get a critical mass across multiple telecom carriers, you don't have too many conversations to have before you can achieve that. In other industries, that is not the case. They are way more fragmented. It is much harder to do that. The third thing here in this list is around ecosystem incentives. I gave you the example of supply chain. I could also give you examples in financial services where different participants really want very markedly different things, and incenting them to participate is difficult. In telecom, you have very similar business models. Having a conversation in a concentrated market with other colleagues to basically create a new service that spans different providers can be much easier. You have the same incentives, you know what your business models are. Having those conversations will be much faster. And then the final piece around regulatory uncertainty, this works both ways. Sometimes the regulations will trail the technology, but kudos to you. In this case, it's actually led the technology. And so it works both ways, but you have an awesome opportunity here created. And I seriously, I'm very excited about the future of blockchain in telecom. We've seen a few examples so far of people applying it, but I think we're literally at the cusp of seeing this expand enormously for the reasons that I've given. So, I hope you have a great rest of the day. I hope this gave you an idea of the potential here and some of the other things that you can do with this, and that this has a really exciting future. Thank you. Thank you.